That's the biggest knob that you're going to have, right? And it's like integral is it's working on that error and it's going to act on that error, but gain is like that big boost that you need. So for our process, for smaller or regular loops, fine with focusing more onto the integral, but for the loops that are high on our disturbance rejection matrix, it's the gain that we have to focus on.
One thing I'd also add to it, it's quite dependent on the system that you have and the controller setup. Because if you have a dependent controller, and by changing your proportional gain, you are acting on that integral term as well, just by virtue of how the equation is set up in a dependent
Mhm.
system. If you have an independent controller, then changing the gain does not impact the integral. And so you will have to be aware and change both of those independent. It depends on, do you want a big boost in your by changing the gain, or do you want a faster response by changing the integral? If you're using the derivative portion in your control, well, if your controller calls for derivative, and filtering that PV is absolutely important because you don't want to amplify that noise. But for 80% of controllers out there should not be using derivative, and therefore you really want to, unless the noise on your PV signal is very high, you want to be very careful about putting any filter